So this little lesson is called Translations, Representations. Okay, so let's get started with what in the world is a translation? All right, so first off, let's imagine that we have a little baseball cap. That is our function. And the reason I know this is a function is that it passes the vertical line test. If you were to draw a vertical line through it, it only touches once at any point on the function. All right, so that red one is going to be our f of x. Now let's imagine that we wanted to represent that same function, except we're going to say that it moved, that's the translate part, moved down 2. So every single point on it is going to move down 2, lower than it used to be. Now I'm going to connect those dots. And now that wouldn't just be f of x anymore. It would be f of x, but I moved it down 2, so I'd go minus 2. Or if I made another one, and this time I moved it to the left 4 spots, then this spot that used to be here goes over 4. Actually, let's make it 6. I just moved it 6 spots to the left. And this spot that used to be here, I'm going to move it 1, 2, 3, 4, 5, 6 to the left. And erase that little oops right there. Okay. And then this spot, it used to be here. I'm going to move that 6 spots to the left. And then this spot that used to be right there, 1, 2, 3, 4, 5, 6. That's going to be right on top of this spot. So here's my little baseball cap now. That's been moved 6 spots to the left. The way you would represent that would be to say f of, and if it's 6 spots to the left, you'd say x plus 6. So you're saying it's still f of x, but it's been changed a little bit, and the little change is this plus 6 on the inside, which means 6 to the left. All right, so let's talk about those changes again. Let's say I just gave you this. That means my f of x has moved 4 spots to the left. And I totally get you might think that that feels like it's 4 to the right. The stuff on the inside goes the opposite way of what you'd expect. All right? What if a kid gave me this? They're saying that the new function has been moved 2 to the left and also down 3. Okay, so some of the problems at the beginning of your homework are going to give you a chart, and they're going to say that you have your original point, and then they're going to say the mapped point. That's the transformed point. So if you had an original point at 0, 0 on the graph, and then your mapped point goes to 0, 3, do you get that the x stayed the same and the y went up by 3? If your original point changed from a 1, 2 to a 1 stayed the same, but it went to a 5, do you get the difference here is all about the y values? Like right there, that changed from a 2 to a 5. This changed from a 0 to a 3. It's going up by 3. Now, why do I say up? Because those are the y values. See, my x's are staying the same. My y controls up and down. And so this one would be changing from 0 to 3 and 2 to 5. That's saying it's going up by 3. If I had another point that used to be on my original, and my original function had the point, let's say 2, 5, then the mapped point would have still been a 2 for the x, but the 5 would go up by 3, and so it'd be 8. So you try to figure out what's changing, the x or the y. And then you got to tell yourself, okay, looks like all the y's went up by 3. Or it looks like all the x's went down by 2, or whatever happened. So in my case, the y's went up by 3. So how do you say that in a function? The answer we want is going to be f of x, except you want to change it to say that the function went up 3. Now how do I show that? Up 3 would be a 3 on the outside. Stuff on the inside would have been a left or a right change, but my x's didn't change at all. All right, so there's my answer for this typical question where they give you the original point and the mapped point. Now let's have you try one. I'm going to give you some original points, and I'm going to map them, and then we're going to see if you can answer like that, and which way it went. Okay, so here's the original point, and now these will be the mapped points. And if we start with 0, 0, and 1, comma 4, and 3, comma 7, those original points, you can't tell anything from those original points. You have to look at the mapped points and say, what seems to have changed on all my mapped points? So if, for instance, on my mapped points, I had -2, 0, -1, 4, and 1, 7, do you see that what I changed there was the x values? So how would you write that with an f of x? Of course you wouldn't just say f of x. That would mean you didn't change it at all. But if you say f of and then you put something on the inside, that would mean I did a x kind of change, like left or right direction. Or if I put something on the outside, that means I did a y kind of change. So I think you can see that all my y values stayed the same in this problem. The 7 is the same as the 7, the 4 is the same as the 4, the 0 is the same as the 0. So the y's all stayed the same. But all my x's went down 2 for this one, and down 2 for that one, and down 2 for that one. So all my x's went down 2. Now, this is down 2, this is up and down. It's on the outside. So down 2, we go -2. Okay? So if the change happened to... No, wait a minute. I just did that wrong. Oh, I'm so sorry. All right, wait. I need to sum this up for myself, too. All my x's just changed and went down 2. So my x's changed. I got to change the inside here. Yes, the x numbers went down 2, but that wouldn't actually move the graph down 2. Just because the x numbers went down 2, x numbers go from left to right. So this point went from 0 to -2, from 1 to -1. They are definitely moving to the left 2 spots. There we go. So what I got confused by is that the numbers were going down, but they were x numbers. If the x is the thing that's changing, that's on the inside. If the y is the thing that's changing, then that would have been on the outside. So there's my correct answer for that question. All right, and then there's one last thing to your homework here today, and that's you have to know how to understand if I give you a domain and a range, what will be the new domain and range if I moved it. All right, so let's talk about a domain and range for a shape, just to make sure you remember what that even means. So let's say my original shape in this case is going to be a little mountain range. It goes like this, then it goes down, then it goes up even higher, and it comes back down pretty steep. Okay, it's kind of like a goofy looking M. All right, what's the domain and the range for that shape? Well, the domain is how far left to right it goes. So the domain on this shape, the furthest to the left that it went was right there at -2. And it goes from -2 to the furthest to the right that it goes, which is 3. The range for this shape is how low it went to how high it went. The lowest that my shape went was a height of 0. And the highest that my shape went was right there. And we're going to say that that is a height of 3. All right, so once I have my domain and range numbers, then if I say, hey, I want to move this thing f of x minus 3, do you get that I just moved that thing down 3? These are so critical. You have to understand when it's on the inside, that's a horizontal, like left-right kind of change. And if it's on the outside like this, then that's a vertical change. I like to say it high, low. Horizontal changes are on the inside, and vertical changes are on the outside. All right, so that changed vertically. It went down 3. So then what's my new domain and range? Well, if my goofy looking M shape moves down exactly 3, then every single point on it will move down exactly 3. And now there's my new shape. Now you don't have to draw it. I'm just trying to show you that if this was the original one was f of x, this new green one would be f of x minus 3. It just all moved down 3. Now what's the domain and the range of this new shape? The domain is the left to right. It's still the same. The furthest to the left this goes is -2. And the furthest to the right it goes, it's like right there, and that's 3 spaces to the right. So -2 to 3. Look, my domain stayed exactly the same. My range is the thing that changed. See, if you change the outside, you're changing the range. If we had made the change on the inside with the x, that would be changing the x's, which would be changing the domain. All right, so since we changed the outside, we changed the range. And our range used to be from 0 to 3, but now the lowest that my function goes is -3. See, like this point right here, that the lowest that goes is -3. It goes down 3. And the furthest that it goes upwards, the highest it goes is 0. So really, couldn't I have just taken my range numbers? If I'd have known that it's going to go down 3, both of my range numbers drop by 3. The 0 goes to -3, that's down 3. And the 3 goes to 0, and that's down 3. All right, so I'll give you one last one like that. Let's say I have my domain and range of my shape. I don't even need to draw it for you. I can just tell you the domain is from 3 to 7, and the range is from 0 to 10. This means the lowest it goes is 0 and the highest it goes is 10. The domain means the furthest to the left that my function goes is 3. That's the x value. These are about x's. And the furthest to the right that it goes is 7. All right, then let's say I tell you that if this is f of x, my new function is not going to be f of x anymore. It's going to be f of x minus 4. Now, you might be tempted to subtract 4 from all the x values, which would be the domain. And you're close. This is a change to the x's, but it's not subtracting 4. Why? Did I tell you this before in this video? You don't trust the stuff on the inside. It always does the opposite of what you would think. To me, this feels like it would move it 4 to the left. It actually would move it 4 to the right. So everything on my domain just moved 4 to the right. So I need to add 4 to this and this. And my range will just stay the same. So my new domain would be adding 4 to the 3 makes 7, and taking the 7 and adding 4 to that makes 11. Notice both numbers went up by 4. Opposite of what you would think. You'd think you'd want to subtract 4 from them. And my range would just stay exactly the same because this didn't do anything to the y values. It only messed with the x values. All right, there's your lesson. Should be able to accomplish your homework now. All your answers typically look just like this. And that would mean like, oh, you moved it 3 to the right. Or this. And that means, oh, you took the function and moved it up 5. All right, that's all I got for you for today.